Good morning, all of you. Last class we two homeworks I gave you. Question number 10 and 11. All of you done? If any doubt for the question number 10, question is this. There is a pentagonal shaped park as shown in the figure. For finding its area, two students use different methods. We want to find out the area of this pentagonal shape using both method. Okay. First method, first student divide the pentagon in this shape. That is, now after dividing this shape we will get two which shapes? Two pentagons. Not two trapezium will get. Okay, two trapezium will be congruent trapezium. Okay, the same area of this trapezium will be for this part also. Now next second students divide the same pentagonal shape in this shape, that is dividing it as a triangle and a square, and they find out the area using that two different methods. Both of them got the same area. Okay, we can also try that. So first this, if you divide this in this way, that is, when we draw a line like this, we will get two trapezium. So for that, first we find the area of one trapezium. So the same area will be for the second trapezium also. Now if for trapezium equation we know, I will just only the clue only I will give, all works you want to do. Okay, for a trapezium, what is the equation? H into a plus b by 2, where h is the height of the distance between the two parallel sides, and a and b are the length of the parallel sides. And here in this figure, it is given the length from here to here is given 15. The total length of this pentagon, that is given 30 meter, and this length is given 15 meter, like that. So in this case, h will be this. Now consider this trapezium. Okay, now what will be its height? Height is this, the distance from here to here. Okay, so height, if it is 15, total 15, it is divided in the center where it will be 90 degree, that is given 90 degree. So this length will be half of 15, so it will be 7.5. So h will get 7.5, and a and b both are parallel sides. One side is this and another side is this. What is the length of this one parallel side? It is 15, and the length of this parallel side, the total distance is given 30. Okay, using this calculation we will get the area of one trapezium. Then if you get the area of one trapezium, multiplying that with 2, you will get the area of this pentagon. Now the second students divide the same pentagon in this way, one triangle and one square. So for this, first we find the area of the triangle, then find the area of square, then add this both. We know here for finding the area of a triangle, we want to know its base and height. If the base, if it is 15 centimeter, this length also will be 15 meter. 15 meter, this also 15 meter. Now height will be what? The total distance from here to here, that is given 30. And this much will be 15, because it is a square, this length will be 15. What is remaining? 15. So this height will be 15. So using that equation, half into base into height, bh. B is given 15 and height also 15. Half bh plus, this is the area of triangle, plus area of square. That is area of square, we know side into side. So 15 into 15. Using this calculation, you will get the area in this case also. After checking, you can find the both area will be same. Okay, so that is shapes area trapezium, and now we discussed the area of trapezium, general quadrilateral, and area of rhombus. All of you understand. Next we want to discuss about solid shapes. Solid shapes also we know what is mean by solid shapes or three-dimensional figures. The shapes which have length, breadth, and height also. For plane figures there is only two dimensions, length and breadth. But for solid shapes there will be three dimensions, length, breadth, and height. And different examples also we know: cube, cuboid, cylinder, cone, like that. All of you know the shapes also. Okay, now in this case we want to find out, in this chapter we want to study the total area of that solid shapes. So cuboid, cube, cylinders, like that. Okay, now when we consider a cube. Okay, cube, all of you know the side of all cubes will be which shapes? Square shape. Okay, and how many total side will be there, how many total faces will be there for a cube, that also you know 6 sides are there. And to find the area, the total surface area, what is total surface area means the area of all sides. Find the total sum of the all sides area. Find the area of one side. Okay. Now find the area of the all other sides. Then take their sum. That is total surface area. Okay. The area of this cube, total surface area of this cube will be, find the area of all sides, all faces. Okay. If it is a cube, always we are representing one side length as small letter A. Okay. Then what is the area of one side? It will be A into A square. Okay. Area of one side. First we are discussing about cube. Okay. Area of a cube we are discussing. Not only area, we are use the word for three-dimensional shapes or solid figures. We use the word total surface area. That means find the all area, all parts area and take the sum. Okay, that is total surface area. Now in the case of another, if it is a cylinder shape, okay, cylinder shape have one, two, three faces, two plain faces, okay, circles, two circles and one curved face. And to find the total surface area of this cylinder, you want to find the first you find the area of this circle and then find the area of this circle and find the area of this part also. Okay, that is total surface area in any, for any shape. In the case of a cone also like that, first we total surface area of this cone means find the all surface area. First you find the area of this face, area of this part, and next find the area of this circle. Take their sum, that will be total surface area of that cone. Like that, first we are finding the total surface area of a cube. For it is, as it is a cube, it is very easy. We know all the sides of a cube is square shaped. Okay, so the area of one square we know. If it is side length is A, area of one side will be what? Area of one side will be A square. Area of one side or one face will be A square. So for a cube there will be 6 squares like this. Okay, so total surface area, for using for shortly we can use TSA. Total surface area of a cube is equal to 6 into A square. 6 faces are there. So 6 into area of one side, because for a square all sides are same. Okay, so it will be easy for in the case of a cube. The total surface area of a cube is, total surface area of a cube is 6A square, where A is the side length of that one side. Okay, now in the case of a cuboid, okay, how we can find out the cuboid surface area? For a cuboid also, just like cube, we know there are how many, suppose this is a cuboid, a small box, pen box is there. For a cuboid, all of you know this is a cuboid shape. Now in this case also, how many total faces are there, how many rectangles are here? Okay, in the case of a cube, there all sides are squares, but in the case of a cuboid, all sides are rectangles. Okay, now to find the total surface area of this cuboid, we want to find the area of each rectangles and take their sum. Okay, for each rectangle's area we want to find out. Now suppose for this cuboid, the length of this cuboid, the length of this box is, take this length it as L, and take the height of this cuboid, the distance from here to here, take its height H, and this part, this is the breadth of this cuboid, and we can represent it as B. Now when we open this cuboid, we will get like this. How many total rectangles are there? 6 rectangles are there. Okay, is it clear? When we open, or net of a cuboid that we already learned in lower classes. After opening that cuboid, we will get 6 rectangle faces. Okay, so first one rectangle is this, second, and this is the third part, this part. Okay, so this is the third, then fourth, then fifth. Here also there will be one part here like that. So that part when we open it will be on the top, and in the lower part that rectangle is this. So here are 6 rectangles. So for finding the total surface area of this cuboid, we want to find out the area of all rectangles, and also here all rectangles are different length and breadth. Okay, so we are considering the first rectangle first. Here this is the first rectangle. Okay, when we consider these rectangles, this length we can take it as its length, and this we know the area of a rectangle, we know its equation is length into breadth. So in this case, totally in the case of a cuboid, we take the height of the cuboid, we take it as h, and the length of the cuboid we take it as length L. Okay, and the breadth we take it as B. So the same length we can take here for finding all areas. So first when we consider the area of the first rectangle, this part, this length, this part into this. So what do we consider this part? This is the height of the cuboid, so it is h. H into what is this length? That we take it as B. So first area of the first rectangle is L into B, not L into B. What is this? H into B. Okay, H into B or BH. Simply we can write it as BH. We can avoid the multiplication sign and we can write it as BH. The area of the first rectangle we got BH. All of you understand? This length we already take it as B, and this length we take it as H. So its area will be BH. And second rectangle when we consider, its length also we can take it as H, and this breadth, what is the breadth of this rectangle? It will be L. Okay, length of the cuboid we take it as this L. So the area of this second rectangle will be L into H. Okay, so plus first we add, then we are adding all the areas. So L into H, LH plus. Then third rectangle, this is it, this length we already know it is B. Okay, B into H, BH plus. And here fourth rectangle also will be the same as these two rectangles are same, and just like 1 and 3, the rectangles 1 and 3 the same rectangles, same size rectangles, and second and fourth also the same rectangles, and its length we take it as H, and this breadth we take it as LH. So that area will be LH plus fifth rectangles, fifth and sixth also will be the same. Okay, now fifth rectangles, its length is L and breadth is B. So LB plus sixth rectangles measures also, this is L into B. Okay, then adding this full. Now first here we can take the like terms here. BH, any other BH is there? Yeah, one BH. BH plus BH we can add together, then we can write it as 2BH. And LH plus one more LH this. So 2LH. Next BH and BH we added, LH and LH also. Then LB plus LB, so it will be 2LB. So in all these terms 2 is common, that we can take outside. So the total surface area of a cuboid will be 2 into BH plus LH plus LB. This is the total surface area of a cuboid. Okay, total surface area of a cuboid is 2 into LH plus BH plus LB. That's 2 equations you want to by head. So total surface area of a cube is 6x square, and total surface area of a cuboid is 2 into, first we can use the area LH, 2 into LH plus, all are same, no problem, but when we use as first we always measuring length, after that breadth. So 2 into LH plus BH plus LB. So that is the total surface area of a cube and cuboid. And using this equation you can find out some example questions are given in the textbook. Okay, all of you try to do these questions. Example 4, this question all of you try to do. Okay, after that do this question also. Only we want to find that, use that equation. Okay, then do this as homework. 11.3 first question do as homework. Okay, thank you.